Hello, good afternoon. Okay, let's get started. So welcome to the lab 1. This is the first lab we have for the course 3331 or 9331. My name's Ray, and we will have labs every week. And this week we will have a look of the course overview because it's the second week. Maybe you would like to know about the details of how we learn this course and what is the content for every week, including the lecture and labs. And the second one is the environment setup, including the labs and assignments. So basically just use the VLabs and Python or Java if you like, and we will have a look at it later. The third one is the Lab 1 content. So we will go through all the questions inside Lab 1. And yeah, if you have any trouble with that, feel free to talk with me or send it into the chat. And yeah, last one, I will also share these slides and the recordings. And of course, if we have some codes, maybe in next week or 2 weeks later, we will share some code with you that may be helpful for your lab. Okay, let's get started. So we can have a check of the course outline here. So I will send you the link, but this link is just on the web CMS. You can also check it by yourself. This one is the course overview. So what I want to mention here is about the score distribution of this course at first. So the labs you have 20% of the mark, and the assignment will have 20% as well. So these two parts, the labs and assignment, is not very hard. Usually you can get at least 80% of the marks. So it will be pretty easy for everyone if you if you have enough time to do it. And the midterm exam is a little bit hard because we will have this one in week 7. So week 6 is the midterm break, and in the week 7, then we will have a midterm test. It will be an open book test, but I would say it's a little bit hard if you didn't have any experience for this kind of test, because even it's open booked, you still require to do a lot of calculation in very limited time. So you may need to pay more time before you attend this test, but don't worry too much because I will go through all the important knowledge points with you at week 5. So just make sure you come to the labs every week, and yeah, and then we will go through all the important stuff. before the exam. And the final exam is just exactly the same as the midterm exam, but of course the content is different. The midterm exam will test the content from week 1 to week 5, and the final exam will test all the content from week 1 to week 10, especially for week 5 to week 10. And another thing I want to mention here is the final exam is a double pass, which means you have to pass the final exam to pass this course. I will share the calculation algorithm here. The calculation algorithm is in here. It's a little bit complex, but it's very easy to understand, which is you need to get at least 16 of the 40 points in the final exam. So that's all the thing I want to mention here. If you have any questions. So the double pass means even if you got 60%, which means you got full marks on labs, programming assignment, and the midterm exam, you still need to get at least 16 on the final exam to pass this course. But don't worry too much about the final exam. Usually, I would say at least 90% of the student can easily pass it. So all we need to pay attention right now is the lab exercise and the assignment. I think we will have the assignment released very soon, so you can have a check of the task of the assignment. But usually the assignment will require you to write the application which can communicate with each other, like the messenger. And in the lab 2 and lab 3, we will have a look of the assignment. Yep. And what's next is about the content overview. So in the week 1, we have already learned some fundamentals about networks. I have not much thing to say because it's very basic, and usually we will not test a lot of theory in the midterm exam and final exam because it's an open book exam. But this part do really help you to understand all the following content, like all the layering and encapsulation of the network. And in week 2 and 3 and 4 and 5, we will learn application and transport layer. Application layer is pretty easy to understand, just the thing we use every day, like the HTTP and the DNS and etc. Yeah, usually it's pretty easy to understand. And week 4 and 5, you may need to pay more attention on it because the transport layer is the most important thing for this course. It will include the TCP and IP stuff. Then you may need to spend more time on it because this part is the core stuff for this course. And in week 7, we will have a midterm exam after the midterm break. And week 9 and week 8 and 9 to 10, I would say this part is not very hard because the network layer and link layer is pretty easy to understand comparing to the transport layer. And the security is easiest thing in this course. So basically just some algorithm, then you may need to just go through the lecture slides. And yeah, it's pretty open-minded questions usually. So if you have any question, please let me know. Okay, so let's come to the lab 1. Before we do the lab 1, I would like to introduce how to do the environment setup. So I'm not sure if you have already checked the content of the labs or not. So we have some we have this part, Introduction to the Tools of Trade. I will send you the link right now. You may need to go through all the content in here in the VLab environment. So you can run the ping command, how to run this command, right? So you just type the command in your own terminal in VLab. So make sure you are running this command in the VLab and try to go through all of them, like and the trace through telnet, SSH. So you can go through all the content here. If you find some problem, let's say you are trying to run this command, but it is not working. For example, in here, you are trying to ping host. It is not working, right? So you need to check out what is the reason for this. Maybe your environment is not correct because I am using Windows right now. But for this one, the reason it doesn't go through is I use the wrong command. For example, here, the ping host, the host always represent an IP address or URL. Usually we use the IP address. So it should replace the host, the host, with some IP address. Let's say 8.8.8.8 is the Google server DNS. Then we can press, then you can see the outputs of it. We can use this command, and it's the same as other commands. So try to search some example if you cannot run it online. So just Google it and learn how to use it. So, but don't worry too much if you feel a little bit hard to understand and memorize it, because we will go through them one by one in the lab 2 and lab 3. So you can just have a quick look. So make sure you have some like basic understanding on this kind of command. At least you need to know like what should we do to run this kind of command and why should we use it. Okay, so you can go through this part by yourself. And next step is the VLab installation. So the VLab is very, very important for our labs and the assignment. So make sure you learn how to run the VLab today, because if you're not running the labs or this assignment in the VLabs, you may get 0 marks as the outcome is different. For example, we are going to like do some ping test or trace roads in today's lab. If you are running in your own computer, you may have totally different outcomes. So the output is totally different. To avoid lose your marks, you should always run your labs and assignment in the VLabs. So we can see how to run the VLab in here. You may have a look of this link I will send to the chat. So you can go through all the content here to set up your VLab, but I'm not going to waste a lot of time on this part. Just have a quick look. The first thing you can access the VLab, and which is the most easiest way, is just click the link. We also have the link in the website, in the bottom of it, in this part, using a web browser. Just click this link, then you will go to the VLab gateway. Just try to log in with your ZID and password, and you will be able to control the VLab and do your labs or assignment. So I will also send a link. So make sure you run the labs and assignment in the VLab environment, because we are expecting to have the same output. And yeah, the web access is very easy to use, but it's not very easy when you want to do the programming, right? Because you may want to copy and paste from your own computer. So you may need to install the Tiger VNC as it described in the website. So you can go through the part 1 and part 2 using a VNC client. before you do the VNC, install the VNC client, you may need to install the what is that? The VPN for your SW. So you can click the link in here, USW VPN. So usually we are required to log into the VPN first, and then we can use the VLab. But in the Tiger VNC, you can use this port number without the VPN. But if you do not understand like what's the meaning of that, you just go through the VPN first. Just install the VPN first and run the VPN, connect to the VPN for our uni, and then connect to the Tiger VNC later. So feel free to ask me any question related to that. Yeah. And that's it. So that's the VLab. This one is pretty important, so make sure you understand it. And next part is the Python and Java installation. So we are not required to use any Python or Java today, but maybe next week and in week 4 we will use it. So you can like install the Python or Java if you feel like Java is better for you, or you can also use C and C++. Yeah, so we support all kind of programming language. There is no limit. Yeah, of course you can use C++, but we recommend you to use Python because everyone can understand Python, and we will have more help session based on Python, because like 85% of the students will do their assignment in Python. So if you do your labs or assignment in Python, you may easily figure out the solution, some of the common question related to this part. Yeah, maybe not Rust. So usually we will support the Python, Java, C, and C++. Yeah, but don't worry too much about it because I think everyone will know at least Python or Java. And yeah, just do the installation. I think most of you have already done it. But if you are like the first year, maybe you all would also like to learn what is the basic syntax, like the just an if command or for loop, something like that, and just go through the basic content to make sure you can like write at least some application for that. And we will also learn the socket programming. So in the Python should be socket library. If you have no idea what is this, maybe you can start from now and try to learn some socket programming from today, because in the assignment we must require you to use the socket programming stuff. So you may need to learn something about it from now, but we will also go through the socket programming from week 3, sorry, from next week lab. We will have some example code to you, and you will also require to write some program by yourself from next week. And exception, because we are going to write an application, right? So the exception handler is very important to make sure your program is not crashed. We will talk about it later, just maybe before the submission of assignment, Python assignment. So don't worry too much about it. So all you need to know is to use the VLab and do the installation of Python and Java. And if you have time, try to learn some syntax and some socket programming by yourself. And you're all set. Can we use SSH to log in instead of VNC? Yes, of course. You can use the SSH, but I recommend you to use the VNC because in today we are going to run some script and it will generate some PDF file or generate some images that you may need to have a look of it. So if you are using SSH, you will be a bit confused if you are not familiar with how to transfer the file between the computers. But yeah, feel free to use the SSH if you want. Okay, so that's all the content I want to mention before we do the lab 1. Let's go to the lab 1 right now. We can have a check. Let me open the first. This one. So we can directly come to here, exercise 1. That's it. And yeah, just try to run this command by yourself. So the first one is to run the nslookup command. Before you do that, you would like to log into your VNC. Let me open mine. So after logging to here, just run the terminal to do the labs. So the first one is nslookup, right? So let's have a look of what should we do, because this one is pretty easy. Let's just go through them quickly. It is asking what is the IP address of this website, right? So we are going to use the nslookup command, nslookup plus the URL, so www.koala.com.au. Then you get some output. So this is the IP address of it. So can someone teach me, like, what is this IP address in the following non-authoritative answer part? Like, does anyone know what is this? This one, comparing to the other one. Yep. Okay, someone told me it's IPv4 and IPv6. That's correct. Yeah, it's IPv6 address. So you can see they are all the answer from this inquiry. So this is the main answer, right? So we know this one is the IP address of this URL. But how about this part and this part? It's also the IP address, right? But it's non-authoritative answer. So which means the computer cannot make sure this one is the official answer. So which means this one could not be the correct IP address, maybe outdated or could be a wrong IP address, but usually it is correct. Yes, this may be because they have multiple server. And we come to the second question. So what's the reason that we have several IP address? We have IPv4, IPv6 in different IP address, right? So what's the reason for that? Yes. So the reason why we have IPv4 and IPv6 is because we want to support the IPv6 addressing. So if the server does not have IPv6 address, it will not support the IPv6 addressing. Yeah, that's the reason why we have this one. So why do we have several IPv4 address? So then you may have lots of reason for that. So one of the reason is balancing. Balancing. So you can have a check by yourself, but this is only one of the reasons. You can also have other reasons. So you can do your own research for this question. And let's go to the second one. So what is the name of IP address? So we just use the same command and let's look up 127.0.0.1. Then you can see the name of this IP address is localhost. So you can do your own research by searching this name online. It's just pretty straightforward. Usually we use this IP address to test our own web application. And that's it. Yeah, we have a question here. Wouldn't the server's IP be hidden behind a load balancer or reverse proxy? Yes, so you are talking about when one server holding different website or URL. But how about like one web application which is quite popular and it may require different IP address in different location for quick access for different user from different area. Let's say my website is very, very popular and like I have 10 million of fans and most of my fans are come from Australia and America. So I may need to set up two server, one in Australia, another one is in America. So both of my fans from these two different locations have very quick access to my website. So this could be one of the reasons that I setting up different IP address, just like the CDN. Okay, so let's go to the next one. Exercise 2. This part is also pretty easy. So just use the ping command. How do we use the ping command? It's pretty easy. Just ping plus an URL or plus an IP address. So let's do the first one. So it's www.uns.edu.au. It will keep pinging to this this URL until you press stop button. So the stop button is the control plus C, which means we want to stop it. And yeah, so obviously we can ping this URL and it will show us what is the IP address of it. And we are sending an ICMP packet with different sequence number. And then it will also give us the time to live and the RTT, the round trip time, which means when we send the packet from our computer, which is the VLab computer, to the server, how long it will take to reach the server and back. So that's the time. You can see every time we send a packet and get a response, the RTT is slightly different. And yeah, that's it. So you go through them one by one, and you also need to open your web browser and try to visit this website for yourself. And then we can draw a table like this. Let me show you. Yeah. So the exercise 2, you can draw a table like this. So for this website, it is pinnable, but how about the web browser? Can you use the web browser to visit it? And if both yes, then you don't need to put any comment. But if like you cannot access it via your browser or pin command, you need to make a comment of it to like explain why you cannot access it. Ping get fit test.com.au name of server not known. Yeah, so you already get the reason that why you cannot ping this website, right? Because maybe this URL is not exist. So make sure you leave the reason in the comment part. And what's next? Exercise 3. You can do here. In here, we need to run the traceroute command to this URL. So let me just take a screenshot. And let's just run it. Run the traceroute command. Traceroute command. Then you have some output like this for this command. So what is the meaning for that? The traceroute command. Like, does anyone have any idea? What is the traceroute command? And how can we understand it? So let me draw something here. The traceroute command is usually we usually use this one when we try to understand what is the how many routers are there between our machine to the destination server. Yes. So when we run the traceroute command, then which means we want to figure out how many routers are there between our machine, router 1 and how many routers are there between our machine and to the destination server. We will check, we will follow our packet, we will try to send the packet to the destination server, and we will trace it. We will have a record of how many routers between us, and then we will list all the information for this kind of router in here, including the time. This means how long does it take from our machine to this server, this router. Is that okay? So can someone tell me what's the answer for the question 1? How many routers along the path are a part of the UNSW network? Yeah, I can see some answer. Does anyone have any different answer for that? So obviously we have 24 rows of outcomes, right? So does it represent we have 24 routers between our machine to columbia.edu? So you may need to read the question carefully. So this one is pretty tricky. Most of the students cannot get it. How many routers are there between your workstation and to this part? I give you one more chance to answer this question. It's not 24. Okay, so because the question is asking how many routers, right? Between. So we don't care about the starting point and the destination. We just care about how many routers between it. Just like the pictures in here. Just like the pictures in here. How many routers in this graph? Only two, right? 1, 2. And even we have 4, you can see 4 clients or 4 machines here. Only 2 routers in this graph. So in this outputs, we can check if this one is the starting point or the destination point, and if this one is the destination point. So because we can see the IP address of Columbia is this one, right? The IP address is 128 point blah blah point 24, and you can also see that it's the same IP address at the end of it, right? So this one is the columbia.edu, which is our destination, which means only this part is the router part. So now you know how many routers do we have. Because we are asking you how many routers. It is not include the destination of it. So you need to be aware of this. This question is pretty tricky. And what's next? So is it 22 or 23? Yeah. Is it? So we know the last one is not, right? Is this the starting point? Is this our machine? This is not, right? This is a router. The first one is a router. Yeah, so just check the IP address to make sure it is a router. So we are counting the router, not include the starting point and the destination. And yeah, so that's the question one. It's just a bit tricky, but it's not hard. Then we can come to the second one. Just run the same command with different URL. And we are looking for the diverge point in here, destination diverge. So what does it mean for the diverge? Let me just draw something here. When we have different destination server, let's say we have destination server 2 and destination server 3, then we may go through different router to reach this kind of different server. Like router 3, I will create 2 more routers here. Router 4, then we may connect to this part and this part and this part. Yeah, so this is the topology of our machine and 3 different destination servers, just for example. So which router is diverge point in this case? Can you like just give me a number? Yeah, obviously it's this one, right? So that's what we want you to do in the second question. The second question, you are required to run the trace route command for 123, this three website. Then you will get a list just like this. So you just get a list for all the routers between them. Then you may need to draw a map like this. Sorry, it's not here. Draw a map like this. So you need to figure out which routers happen to diverge. Maybe I would say probably somewhere here. So because this part is the UNSW network, right? So if we want to send a packet to the outside, then we will go to the UNSW router and we will go to the ISP of UNSW, and then we will go to different city and somewhere else. So probably at the beginning of it, somewhere here, I guess. So you need to check these three different outputs and draw this kind of map to get the answer. So just draw this kind of map and find the diverge point. Of course, you can also just write it down. So the drawing the map is not compulsory, but it makes us easy to understand your answer. What's next? Yeah, and find out further details about the router. So if you find the router 2, which is the diverge point, then you can find more details about it. So I just have an example for this, like this one, 138.44.5.0. So how can I get more information for this IP address? We use the whois command, 138.44.5. Whois command plus the IP address, then you can get the uh, details of it. Can you try to run this by yourself? Okay, so you may have the same output as mine, right? AAR and ET, PTY, LTD. So this one is our ISP for UNSW. So you can have a double check of it, which means like at least this router or this line, that line is supported by this company. So which means this company probably is the internet service provider for UNSW. And the location is in Kensington. I don't know why it's in Perth. Maybe their company is in Perth, maybe. But obviously, Kensington is not in Perth. Okay, so here are the details of it. So you know uh, which kind of command are we using? It's the whois. You can also try to use this command by yourself with different IP address. And of course, you can check out this website, you get signal. So basically just transform the IP address to the location. Ah, it's my bad, sorry. The Kensington is also a suburb in Perth. Yeah, sorry for that. But at least we know this IP address is not in Perth. You can check the check this out just by click this link. And yeah, next one. We are doing a reverse trace route. So in the task 3, it's different from task 1 and 2. The first 1 and 2 is requiring us to like trace from our machine to the destination server, right? So it's in this direction. How can I feel it? Don't worry. Just you know my idea, right? So it's from our machine to the destination server. But sometimes we have a lot of routers between the destination and our machine. So this route maybe not the only possible that we can reach the same destination. So maybe we have another router, right, between them that can directly connect to the destination server like this. So sometimes the packets from our machine to the destination server go through the different routers. And of course, from the destination server to our machine may also go through different routers. So we want you to have a check, like, is there any difference between the packet to like from our packet, from our machine to the destination and from the destination to our machine? So you need to compare like what is the difference between we send the packet to the destination and send the packet from destination to our machine. So how can we do that? Is we can open these two websites, speedtest.com.sg, which means Singapore. So speedtest.com.sg. You can see it's a Singapore website. You can also test your speed, but we are not going to test speed here. It's just the tr.php, which means trace route. This means we can put our own IP address here and then submit it. And it will run the trace route command for ourselves. So which means we will run the trace route command in their server to our IP address. So you need to figure out what is your IP address. It's pretty easy and to get your IP address. You can just simply search IP ADDR. And what is an IP address? Sorry, just not the answer. Just, yeah. So you can check your IP address by just open one of the website online. It will easily show your IP address and what is the location. Yeah. Yeah, for example, mine is in Cooper Service Data Center. Yeah, yeah. So do not ping my IP address. Thank you so much. Okay, so now you got the IP address, how to get it, right? And just put the IP address, for example, this one, and just submit it and run it. And of course, in your own computer, you also need to run the traceroute command, and you will get a similar output and comparing them and see what's the difference from our computer to the server and from the server to our computer. Okay, is that okay for this this thing? Okay, so let's go to the next one. Mm, Next one, exercise 4. Before we do the exercise 4, you may need to download the script in here. Just click the link, then you can see there is a script. You don't need to worry too much if you cannot understand what's inside. We just need to learn how to run it. You can just understand we are using a script to send a lot of ping command to different URL, like with different sites. We are sending a lot of packets to the destination URL and try to figure out what is the round trip time for that. So just download the script. You can also find it in the top on the top of it. So there are two scripts, run ping.sh and the plot.sh. There are two shell scripts that you need to download into your VLab. So try to download it right now and we can run it together. Yes, so download them into your VLab. For example, in here, I have already done it. Just put it inside the VLab. Let me delete the unnecessary file at first. So you can see already in here. So do the same thing as me. And yeah, let's just try to learn how to run the script at first. So in order to run the script, you may need to put it in somewhere in your VLab, and then how to run it. It's not double click it. It will not work. Just right click and open the terminal here. Oh, of course, if you are running the terminal in SSH, maybe you have already know how to run it, but just in case you have no idea how to run this kind of script, we need to right click it, open terminal here. So we enter this folder directly. You can have a check of current folder as well. So you just type the ls command to show what do we have in this folder. We have plot.sh and runpin.sh. So we can run it. And you can also have a check in the specification here. So we are in here right now. We are going to run this command. So simply copy this part. But before you do the copy, run this part, you may need to check out this part, chmod runpin.sh, because if you download the file from the website, you may need to give the access to the in the Linux at first. So you need to run this command at first, chmod, which means you give the access of writing and creating and changing the file to this script, runping.sh. So this script now have the access of the file, or it can create new file in the same folder. And then you can run the runping command, just runping.sh.uq.edu.au. And you can see it is starting to generate a new file in here. So we also got a warning here. Don't worry about it because this one is still running. So all we need to do is just wait for this command, because this script is sending a lot of packets into this URL. So we just need to wait for that. Usually it will take 4 to 5 minutes. And you can also check about the file size. You can check the file size is increasing, right? It's 4 KB right now, and create another one, and the file size is also increasing. So just wait for that. I am stopping download the files. Okay, so what's your what's the problem for that? Any trouble? The easiest way to download the file is to use the browser. So you have the browser, just log into the web CMS and go to the lab exercise, and then find the script, go to this part and click the download button, then you get it. Yep. Of course, if you cannot log into here, have some trouble to log into the web server or access it, you can also use the email to send it. The easiest way is to just go to the web CMS with the this one. So open the Chrome here. Open the Chrome. Yeah, so you don't have the access. You can just go to the email, I think. Try to log in to your email and send it. Or you can also use the terminal to send a file. Yes, SFTP. Yeah, we are waiting for the running of this script. We are just waiting here. If you have any trouble, just let me know. Yeah, SFTP is not very easy to understand at first. You may need to learn like the basic of Linux by yourself at first. Just search online. Just search online like uh web basic, Linux basic. Just go through this kind of tutorial by yourself if you have time. Yeah. So the easiest way is just use the browser to send it, or you can upload to your Google Drive or somewhere else, send to your Google Gmail or something. Yes, I have already done the chmod things. So to run this script, you need to run the chmod at first, and then run the script after that. These two commands. And you can see it's quite long to run the command. Just need to wait for that. It says this quarter exceeded. Yeah, because I used my relay too much. I got too much stuff. I may need to delete them all. Delete. Okay, so just wait for that. Let's see what's next. After we run the run pin.sh, The next thing is to plot it. Just run another script for that, right? Just have another screenshot. So there are two steps: run paint.sh and plot.sh. So yeah, you can see now it's finished. Then we can see what we have in the folder right now. You can see 1, 2, 3, 4, 5, 6, 7. We have 7 files. Yeah, but I don't know, probably these two have some problem because I have some error when I run the command. But anyway, let's try to run the plot command right now. The same one, open the terminal, and just run the command plot.sh and uq.edu.au. You can see it will get lots of information here, and it will generate a PDF file. Wait, PDF. Oh, it doesn't work. I don't know, but I think this is because the WeLab have some problem with opening this kind of files. So I may need to use the web browser to read it. Okay, so yeah, just be careful when you have this kind of outputs. Your outputs may be different as mine because maybe I encountered some error when I generating the files at the end of it. You may have different outputs at the end of it, but don't worry of it. As long as you can generate this PDF file, then you can check how can we understand this kind of stuff. So we are sending a lot of ping packets, which is the ICMP packet, to the destination, which is the uq.edu.au, University of Queensland. And you can see with the packet size increased, the delay increased as well, right? So which means when we send the larger packets, the delay also increased. And what's the average delay? You need to have a read of the generated file by yourself. You can, I think it's in the TXT file in here. You may not be able to open it directly because we have some problem with our text editor in WeLab right now. They are working to fixing it right now. So you cannot double click and open it, but you can use the terminal to read it. The uq.edu.au abg. Yep. So I'm using Vim to read it. You can also use other method to read this file. As you can see, this is the average of RTT here. 117, 17. And I do have some loss at the end of the file. So make sure you have everything inside this file. So now we can get the RTT round trip time from our machine to UQ. So how can we do the exercise and answer all the questions here? We need to figure out what is the physical distance at first. So let me go to my slides. The slides is in here. For the question 1 and 2, we need to do the calculation. We need to calculate what is the value of t. So the t equal to the physical distance divided by the speed of light. So if you still remember what have we learned this week and last week, you will know that t is actually a delay. Do you know what kind of delay is that? We have 4 kinds of delay, right? So the t is one kind of delay that we have learned before. Like if you still remember. What is this delay? Yes, it's propagation delay. But don't worry, we'll have a look at it later. But let's just focusing on how to calculate this kind of t. Let's focusing on how to get t value at first, because in the question 1, we need to do the calculation for the t value somewhere between in here. Yeah, what's the t value for that? To do the calculation. So to get this value, we can draw a table like this: host, distance, RTT, T, and ratio. So I will give you some hint how to get all the values in here. So the host is just from the question, right? And the distance, we can use the Google map to do it. Just to use the VLab and just run the web browser maps, right? So from UNSW. So that's the UNSW. We can start from the CSE building. CSE building is somewhere here. So measure distance. We just click the CSE building. Sorry, made a mistake. Again, right click, measure distance. Then we go to the UQ, University of Queensland. Let's just come to here. So you can see it's 734 kilometers. Yeah, 734. So just draw the graph. But in here, I just put 750 to make it easier to do the calculation. But you may need to change this value. And what is the RTT? RTT, which means the round trip time from our computer to UQ, right? So we can get this value by running the script. Do you still remember we got lots of file in here? So we just open this file, the txt file, or the PDF file we had. Just have a look of this file. You need to get the average value. So in here, just roughly estimate overall average is 70-ish. You need to get the true average data, but I'm just only doing the example here. So I just put a random value here, just 40, okay? But now you got the idea. We need to extract the value from the generated file. And what is the t value? The t value equal to the physical distance, which is 750 kilometers, divided by the speed of light. We have indicated that the speed of light is 3 times 10 by the power of 8. I think it's in somewhere here, right? So we just do the division by ourselves, and we will get 13 milliseconds. So what does this mean? So just I put this simple calculator here, 750 because it's km. So we add 3 more 0 in here, divide by the 3, following by 8, 0. Yeah. So, yeah. So in here, we are requiring this much of time to reach the destination. So in here, actually, my value is wrong. So I may need to mark. Sorry, I may need to mark here. I might need to. It actually is 25 2.5. Is it 2.5 ms? I made a mistake. I'm sorry about that. So it's 2.5 milliseconds to reach, because the physical distance is in here and the speed of light is 3 times 10 by the power of 8. Yeah, just do the division and you can get a value of that. And what's the ratio for that? So of course, the ratio is wrong as well. So just 40 divided by 2.5 probably is 16 ratio. So which means ratio equal to RTT divided by T. So now we can check what is the meaning of calculation of T. I think I can see Jason have answered it. The reason for that is the minimum possible time for the packet to travel. That's correct. So because we want to send a packet from Queensland, from UNSW to Queensland, and the minimum possible time to reach there is 2.5 milliseconds, which means in the future, if we have very advanced fiber, have zero delay on other delay, excepting the propagation delay, then we can reach this speed. If someone tell you in the future they can reach 1 point something millisecond to send a packet to Queensland, you may think that's not true, except they can break the speed of light. So this means currently we can have this one as our maximum speed to reach Queensland. And so why the RTT is so high comparing to the theory value? So comparing to this one is 16 times than the theory value. So what's the reason for that? So let's say if we can really do the maximum speed that we can reach right now, the ratio, what's the ratio? Like what is the minimum value of the ratio? The minimum ratio. What is the minimum ratio for that? It's actually 2. So what is 2? It is already inside in here, right? So at the end of the question. So what do you think? At least 2 reasons that are greater. It must no smaller than 2, right? So the minimum ratio is 2 because we need to have at least 2 times t to reach it, because it's round trip time. So the RTT is round trip time, but this one is just one trip. It's not round trip. So you need to know what is the meaning of round trip time right now, because we will go to the server and comes back, which means we will do 2 times of the physical distance in here. And that's the reason why the minimum ratio is 2. But in fact, the ratio right now is 16. So what's the reason it's 16 instead of 2 or 2 point something? It's way more larger than 2. Like any possible idea? Delay in router and switches. Yeah, exactly. You can use what have you learned in the lecture to explain it, because we do have lots of other delay, right? This one is just propagation delay itself. We still have the queuing delay, transmission delay, and the processing delay, etc. So you can explain by using the content in the lecture slides. And another thing is because we check the distance, we check the distance in the Google map, right? It may not correct. Where's my I think yeah, because we check the distance on the Google map, which is just a straight line from Sydney to Brisbane. I will just use this method to do this checking because it's a straight line. But as you can know here, the fiber is not a straight line. Usually the fiber will go to the like Newcastle at first, and it will go to another city. So it will not be a straight line if like that. So usually we will have the fiber like to Newcastle and to another major city and to the Gold Coast, and then finally to the Brisbane. So actually the fiber is longer than the straight line from Sydney to Brisbane, right? So the actual physical distance is longer than the calculation of of the t. Now that's one of the reasons. So you can have more reason for that. You can figure it out by yourself or do the searching by yourself. And yeah, the question 2 is pretty easy, and just answer this one on your observation. And the third question is about the content of on the lab, on the lecture, sorry. The measure delay, this four kind of delay, right? And which of this delay depends on the packet size and which are not. So let's just have a quick look of the last one. So in here, I would like to go to the lecture slides. Maybe in week 1, I guess, the application delay should be in here. So just search delay. No? Sorry, maybe the wrong one. Just give me a sec. I need to find out where is that. Maybe in the week 2 introduction, student introduction. In here, I guess. Yes, part 2. It's about the delay. Delay, yeah. So we are looking for the delay stuff here. Oh, it's not in here. Oh, this one is not in here as well. Maybe in the lecture slide notes. This one. Oh yeah, I made a mistake. I'm sorry. It's in here. So it's a bit complex when I want to search this kind of content, especially in the midterm exam. So you have lots of lecture, and for example, you want to search the delay. Like me, I may have spent a lot of time to do the search by checking all the different slides. So before you do the midterm exam, you also need to try to merge all the PDF file, merge all the slides into one file. So we don't need to go through and check different files. But let's just have a look of this four kind of delay here. So this part is important. We just need to know when this kind of delay happened at first. So we know we have four kind of delay, but which one is the first delay we encounter for the packet? Which one is the first? So let's say we have a packet from here, and we are going through this router and then reaching our destination here. So the first delay happened in here, in this place. Sorry for my drawing, so bad. In this part, what happened? The processing delay, right? So you can consider this packet is just like a mail that you want to send a mail via the post office to the destination. So when your mail go to the post office, and they will check what is the destination of this mail, and if you pay for the mailing fee or something like that, they will also check if your mail is valid or not. If your mail is like it's not complete, they will drop your mail, just something like that. Now you got the idea. We are sending our stuff, and it will specify what is the destination. And when we reach the router, it will read what is the destination of it, and then forward to another router, or just directly send to the destination if they can. So the first one is to do the processing. So they will need to understand what is the destination or other critical information for your packets. And the second one is the queuing delay. Queuing delay, which means inside this router, they may have lots of packets to wait to be sent out, right? So if this router is very busy and connect to a lot of computer, and they are trying to send a lot of packet to the outside right now, it may have the queuing delay. But in the calculation, we usually do not care about the queuing delay, or they will giving you a fixed value of it. So usually we don't care too much about queuing delay. But this question is, does it matter with the packet size in here, right? So does the processing delay related to the packet size? So when the packet reach the router, does it matter? Yeah, it's still the same, right? That's still the same idea. When we send a packet from here to when we reach to the router, so let's say when you send a small small document to the post office, and comparing to you send a huge package to the post office, does it matter for them to process your packet? It does, right? If your packet is it's huge, then they may take more time to unpack it and read the information on it. But usually the packet is pretty small, and they will like be very fast on it. But the packet size does affect the processing delay. Yeah, so this part is yes. And how about the queuing delay? The queuing delay. So I have explained you, it only depends on the traffic, right? So usually it's not about the case for the packet size. And how about the transmission delay? So the transmission delay happens in here, happens in this part. So when the router have done the routing and processing and queuing for your packet, and it will ready to be sent out to the next destination. So it will do the transmission to the outside. It will send your packet to the internet, and it will go to another destination. So that's the transmission delay. And we always talk about the speed of transmission delay. So transmission delay equal to the what is that? Path packet size divided by the bandwidth. And let's say we have an example for that. Let's say your packet size, just for example, is 100 MB, and your bandwidth is 100 Mbps. So can you give me the delay of transmission? Give me a number for that. Can you do the calculation for me? So this one is one of the question in the midterm exam. It used to be, but maybe not in this semester, I guess. Okay, now I got lots of wrong answer. Okay, so let's do the calculation. So you need to understand what is MB. So 100 MB equal to 100 million bytes, right? And what is 100 Mbps? Equal to 100 million bits per second. So now can you give me the answer? So this is the hint. And one byte equal to 8 bits. So you can see there is a conversion between the units. Right. So now you got the idea, right? So it's equal to 100 times 8 divided by 100 and times 1000 because it's millisecond, right? In here is per second. So that's the answer equal to 8 ms. Okay, so you can see to download the 100 megabytes file, you need at least 8 minutes, 8 seconds if you have the bandwidth of 100 Mbps. So you can also have a check of your own bandwidth. Let's say you are using 25 Mbps and how much of MB per second. You can try to download a file and check if this one is matching your speed. Right? Just simply divide by 8 usually. And if you are using a 100 Mbps of bandwidth, and you should be able to achieve 12.5 megabytes per second in download speed. So that's just some fundamental of our network, and we will discover more about it in the future. So this kind of concept is not necessarily in labs, but it's very helpful in the midterm exam. And in the week 5, we'll go through all the important this kind of stuff later. So don't worry too much if you feel a little bit confused of it. Just pay more time on the lecture slides. Yeah, and that's all for the content for today. We have go through all the content in the labs. I hope you feel it's not very hard to understand. And I have put like some notes in this one. Sorry, it's lab 1, it's not lab 2. It's my bad. Yeah, and that's it for today. And I will share the slides later in the GitHub link. I'll send you the GitHub link. And you can also check out the recording if you like. We already put the recording link into the web CMS. I will send the slides into this GitHub link. I will upload to this link later. Yeah, and that's it. We still have half an hour. If you have any trouble, just let me know. You can open your microphone or just type it to me. Yeah, and feel free to leave if you have no problem with it. And thanks for coming. I would like to see you every week.